Hello everyone. I am Uttam Satpute, Professor Electrical Engineering Department at D.Y. Patil College of Engineering, Nagar. This is video number 8 on traction moment and energy consumption of the subject electrical generation utilization of 8th semester. In this video, we'll see what is how you calculate the energy required to propellate the train. So uh, let us understand that already we have seen what are all the forces. The total active attractive force also we have calculated. So the total attractive force, it is the force required for acceleration plus the force required to overcome the gravitation and plus the force required to overcome the train resistance. So this is the total attractive effort. Now energy, simple it is equation is that energy is equal to force into distance or the work done. So how this distance now we have to calculate from the our speed time curve. Suppose this is our speed time curve. I'll take the simple uh, trapezoidal and simplified form of speed time curve. So this is the acceleration period T1, and this is the free running period say T2, and this is the retardation period T3. Now, where all total energy required the move the train from start to stop, how to calculate the total energy. Now here one thing we have to find out, we have to find out what is the energy required during acceleration. Then we have to find out what is the energy required during free run. And here you don't require any energy. During retardation, the power to the motor is turned off. It moves by its own momentum. So there is not no energy is required during retardation. So only energy is required during acceleration and during free run. Now, how to calculate the energy? As I told, force into distance. Now, the tractive force here, tractive force, it is Ft we have. Now, how you can calculate the distance? You have to simply calculate this area. Area. Now, how you calculate the area? We know half Vm into T1, where Vm is the maximum speed here, and then if you multiply it by Ft, then we'll get what is the energy during acceleration. So what is the equation here? It is used this same equation. Now this 3600, one more additional term it has come, I think only one three term. Now for this 3600, it is because this Vm whatever it is there, it is in kilometer per hour. So to convert it into uh, meter per second. I think 1000 is required in the numerator. Kilometer energy required during acceleration. So, okay, so this is what the equation is there to find out the uh, energy required during acceleration. Similarly, this is the second term. It is used here to find out the energy during free run. So it is simply again the area of this area will give you the distance. So Vm into T2 will give you, we have to take care of the units properly. So Vm into T2, and if you multiply B with Ft, the tractive effort, then we will get the energy during free run. If these two we are added, then we will get the total energy required for propulsion of the train. Now, for comparison reason, this energy is divided by weight and even the distance covered, and that is what we call it as specific energy. This is very very important term that is introduced. So specific energy here, it is given by this equation. So this is the equation for the specific energy. We can write it as like specific energy Sc. So Sc is equal to energy output in watts Okay, divided by weight of the train into distance of run. It is only distance of run. Okay. Okay, so in kilometer, distance of acceleration plus run, totally it will be total distance. So this is called as specific energy output. Okay, but this is only the energy required to propulate the train, but there is energy required for lighting, heating, and all. If that energy is also taken into account, then the total energy consumption, this is not the energy output, then the energy consumption. Energy consumption is the total energy give input to the train, including lighting and heating and control and braking. If you add all the energy with this energy output, then we'll get the energy consumption. And if you divide it by weight of the train in tons and the distance of run, then we'll get the specific energy of consumption. Specific energy of the consumption. So there are two types of specific energy. One is specific energy output and specific energy consumption. So okay, so in this video only up to this only, and one more point I would add, there is a derivation here actually. Now how you can find the equation for the specific energy output and specific energy consumption? Simply, now we know the energy equation, so from this you can find out the energy from this equation. Okay, so from this equation we can find out the energy, and if you divide it by weight, now here we have to substitute Ft. Ft, it is given by Fa plus Fg plus Fr. So all that equation we have to substitute, some manipulation you have to do, some unit conversion. Then we can find the energy. Energy divided by weight and the distance will give the specific energy output. And if there is a lighting energy required or for heating, if that energy is added to the energy output, will give the total energy. And if that is divided by weight and distance, then that will give specific energy consumption. So this is all about the specific energy of the train required to propulate. So the in this video up to this only. Thank you very much.